is the fifth tutorial example where we're going to look at how can we handle interventions in time series. What we mean by intervention is typically what happens when you have sensor failure. So when you have sensor failure, it typically takes several weeks or several months to get this sensor either fixed or replaced. And typically what that happens when you fix or replace the sensor is that you're going to reinitialize it. So you're going to reinitialize its position. So what you're going to observe in your time series is a bunch of missing data followed by a shift, because when you reinitialize, you're usually not perfect in the position you're going to initialize it and compare with your previous location. So what we have in OpenBDLM is a new component that allows to automatically find what is the optimal correction we need to do in order to avoid having jumps in your time series. So what we're going to do with example 5 is to review the data we had in the first example, on which we manually added missing data as well as deterministic shift that are going to be automatically estimated with OpenBDLM. So to do this, what we're going to do is open the configuration file in OpenBDLM config file. We have this CFG example, this intervention with optimized parameter value. This is what we have here. So now this data set is similar to what we have for example 1, as I mentioned, except that we have these missing data and shift that simulate sensor failure, or at least the replacement of the sensor following a failure. So here for the hidden state component, these are the exact same as for the first example. So the baseline, which represents the baseline response of the displacement, 2 periodic component, 1 yearly, 1 daily, and 1 residual term. And on top of these 4 components, we add the level intervention, number 61. What number 61 does is that for the time step that you provide into the vector data.interventions, here I have 2 locations where I have jumps. We're going to see that later on. It's going to estimate what is the perfect correction I can have in order to avoid having any jump in my time series. So it understands that it needs to estimate a correction for these 2 time steps here. And here I already pre-estimate all my parameters that are given here. So the parameter optimized here are exactly the same parameters as what I had for my first time series. So what I'm going to do is that I'm going to go here, copy this name, because I want directly to preload this config file. So I'm going to go in OpenBDLM main, and what I'm going to do, I'm going to have these quote, and I'm going to load this file. Oh, sorry. And now everything is loaded. What I can do is to show you the data. So if we want to display the data, we can go in option 14. We're going to look at the data, and we say plot the data, option 1. So here we have the time step. So the time step here is indicated. I cannot show it here, but this is a time step of 6 hours as for our first example. And what we can see here is the raw data. So this is my yearly component, and you can see that here some data is missing. And here the match between these 2 is not correct, because it's similarly the case where when we reinstall the sensor, we were not perfect into our repositioning. And this is also obvious here. We have missing data to represent either the data acquisition or sensor failure. And once we reinstall the sensor, we see that we have some deterministic shift in the data. So here what we did in our config file, the 2 timestamps we provide, data.interventions, correspond to the timestamps we have here and there. The 2 timestamps for which we want to be OpenBDLM to learn what is the perfect correction to apply on this time series. Okay? So what we're going to do here is to directly, we have already learned the parameters. We've already estimated the initial hidden states. So what we can do here is to estimate the hidden states for the whole time series, including the correction required at the 2 timestamps provided here. So if we choose option 3, we want to use, for instance, Kalman filter here for option 1, or we could have chosen as well Kalman smoother option 2. So here we choose to take Kalman's filter. What we can see here, this is for our local intervention hidden states. What you can see here at the beginning, I have nothing happening. The first jump occurs at my first timestamps I have defined here. So what you can see is that it estimated what was the required correction. That was due to the shift that was introduced in the time series. The second jump you can see here is what is the correction that is caused for this at the second timestamps I provide in my config file. So if we keep that in mind, what we have here is the autoregressive term that we have here that you see it's stationary. So the autoregressive term is not capturing any of these jumps because these jumps are captured here by my intervention component. So if I wouldn't have this, most likely that my autoregressive term would have jumped all over the place. The quality of my estimation would be much lower. Now I have here my daily periodic component. This is my second hidden states. I don't really need it. My first one, this is the second hidden states for my yearly periodic component. I don't need this one. This is my first hidden state for my yearly periodic component. This represents my external effects. So my seasonal effects occurring on my data. And here what you can see is the local level. So local level, despite having these jumps, has not changed. So we can see here in the raw data, we can see well what are the effects. So OpenBDLM automatically fill the gaps here and apply the correction. So the jumps you can see in the time series here, I'm gonna quit this. So the jumps you can see in the time series here correspond exactly to the correction that are required to compensate for the shift we have, in our case, manually introduced in the raw data. In practice, this is going to be caused by, for instance, replacing a sensor. When you replace a sensor, it's not at the exact same position. Automatically, OpenBDLM allow you to correct for it. So at the end, when you look at your baseline, the response of the system without the external effects, here we have as external effects the daily and the seasonal variation, we can see that we can isolate a very clean baseline that will allow us to track is the system in a normal or abnormal condition. Is it accelerating? Is it having a constant speed or whatever?